Welcome back to the tutorial on discriminant analysis. Here in this session 2, we will see how to estimate a discriminant analysis model using SPSS. We deal with a dataset on loan defaulters. The objective of this analysis is to predict whether a person who owns a bank loan would be a defaulter in the upcoming month or not, for which we would be dealing with 8 independent variables, and the dependent variable is the existing data set. From the existing data set, whether the customers had been defaulters or not. If a person is a defaulter, he is assigned the value 1, and if he is not, he is assigned the value 0. The independent variables used are age in years, level of education, years with current employer, years at current address, household income in thousands, debt to income ratio, credit card debt in thousands, and other debts in thousands of dollars. Just to have a glance at what is the type, what is the data type here, we check the frequency of one of the variables. Say, let us consider the descriptive of level of education as well as previous defaulters. We can take any of the variables, not necessarily these. Okay. Using the descriptives of these two variables, we see that there are 700 observations in the data. Using the frequency option, checking the previous defaulters, we can see that there are 700 observations in the data. That is, the data set consists of 700 customers who have loan, and out of them 183, that is 26%, consists of 26.1% consists of people who had been defaulters, and 73.9% of the members weren't defaulters. So from this 73.9 and 26.1, it is evident that we are not having a balanced data set, or the dependent variable is not exactly in the ratio 1:1. Okay. Let's see how to perform discriminant analysis in SPSS. Yeah. We obtain the option for discriminant analysis from Analyze tab, under which Classify provides us the option. In discriminant analysis, we are to provide the grouping variable, which is the defaulter, which has a range defined from 0 to 1. That is, the minimum and maximum value which classifies the data is to be provided. If the division has more than 2 values, then the least value and the highest value are to be provided here. This is just a division of 2 values, hence we are providing it as 0 and 1. It can also be 1 and 2. Usually it is a consecutive set of numbers, and the rest, all the variables are considered as independent variables. In the option of statistics, we check univariate ANOVA and also means of the variables. We also require the unstandardized function coefficients. From the classify option, we need to check definitely summary table, which will help us to understand what is the model accuracy that is estimated, and also from the prior probabilities, if we had a data set which is in the ratio 1:1 with the two classes, then we would have gone with all groups equal or at least close to 1:1. Here that we have a totally unbalanced data of 79 and 23, or 76 and 23, 24%, we are going with compute from group size. And let us save the predicted group membership and discriminant score later on to see what is the prediction accuracy of the model. And when we click on OK button, you get the output window open, which gives us the result of our discriminant analysis model. There are a lot of tables that have come up when we require discriminant analysis model, of which not all tables we will require for the present study. The main tables that we will refer to are canonical discriminant function coefficient, which is the function that we require. Then the discriminating function centroids, group centroids, which will be the decision value to classify a person into yes or no category. We will also be interpreting the classification result, which indicates 81.3% correctness in the model that is generated. And we will also be explaining the means and test of equality of group means.